Hello, my mathematicians. This is Miss Foster with Math in Focus, 4th grade, Chapter 6, Lesson 6, Renaming or Simplifying Improper Fractions or Mixed Numbers when Adding or Subtracting. In our last lesson, we talked about going back and forth between improper fractions and mixed numbers. They're kind of the same thing. They're all both greater than 1. Sometimes the whole thing is put together as a whole thing, and sometimes those whole things are broken into lots of pieces. And one of the places we use this is when we're adding and subtracting fractions. On this page, we're going to add 2 fractions, and we're going to get a mixed number. So Warren and Drake each had an apple. Warren ate 7/8 of his apple, and Drake ate 3/4 of his apple. What fraction of the apples did they eat all together? Well, I might want to write this as a addition problem. So I've got Warren, he ate 7/8 here, and then I've got Drake, and he ate 3/4. And of course, the problem here is that I can't add eighths and fourths because they're not the same. I have to find a common denominator. And I notice that this thing keeps happening a lot. If I'm trying to find a common denominator for addition, I'm often making the pieces smaller. Now, if these are fourths right here, 1, 2, 3, 4, 1, 2, 3, 4. But we noticed, and they've already done this for us, that we can cut these things into 2 pieces each, and those are eighths. So the way that we would write this out mathematically, we'll say, well, I'm going to use 8 as my common denominators, and that means I don't have to change my 7/8. They're already eighths. But I can use multiplication to turn 3/4 into 6/8, way down here. All right, so that will be 6/8. 4 times 2 is 8, and then I'm going to multiply 3 by 2 also. That gets me to 6. If I add all of that up, I land on 13/8. Hello, improper fraction. Now, if I wanted to express this in its simplest form, of course I would say, well, how many groups of 8 can I get out of 13? 1, and that would give me 1 whole apple. Now, what is 13 minus 8? Because I just took 8 of those pieces to make 1 whole thing, right? So 13 minus 8 equals 5, and that would leave me with 1 and 5/8. Is this in its simplest form? Well, 5 and 8 only share a common factor of 1, so I'm going to say yes. Now, since we are able to add things into improper fractions and then make them mixed numbers, because we understand all of this, we can start adding all kinds of crazy stuff. Like with this problem down here. We've got 3/4, 1/8, and 5/8, and we want to find the sum. The SUM sum is the answer to an addition problem, so you'll notice that they use the addition operation over here. And we ran into the same problem we always seem to run into with addition and subtraction of fractions. We've got to have the pieces be the same size. And so we see that, oh, well, 4 times 2 equals 8, and we have noticed a trend about getting smaller pieces if we're trying to work it all out. So 3 out of 4, 3/4, if we multiply it by 2 halves, will become 6/8. And then we have all these eighths to add together, and that will get us to 12/8. Now, we have some choices here. We could simplify this like they did first. Do you see what they did down here? They said, well, 8 and 12 share a common factor of 4. And 8 divided by 4 equals 2, and 12 divided by 4 equals 3. And then they said, well, if there are just 2 pieces here, that'll be a whole thing, leaving 1/2 left over, and that's how they got over to 1 and 1/2. Let's try this together on this slightly larger problem. I've got 5/6 plus 1/12 plus 1/6, and oh my goodness, I can't add them because they're all different things. But 6 times 2 equals 12. Now you might be thinking, but wait, Miss Foster, 6ths are bigger than 12ths, and so they are simpler to think about and work with. And I would say, yes, my darling, you are 100% correct. However, I can't divide 1 by 2 into a whole number. And fractions of fractions, let's save that for middle school, shall we? So I'm just going to go ahead and make these 6ths, these fractions, into 12ths. 6 times 2 is 12. So 5 times 2 is 10. I have to multiply the denominator and the numerator by the same factor so that all the pieces are the same size. And I already have 1/12 here. That's good to go. And then I've got 1/6. Well, what's the relationship between 6 and 12? 6 times 2 is 12. So if I'm doing 6 times 2 to get to that 12, I'm going to have to do times 2 to that numerator and get a 2. Now I can add these up and notice that I have 10 plus 1 plus 2, and that equals 13/12. Awesome. But when we have an improper fraction, we want to simplify it into a mixed number. So how many twelfths can I get out of 13? Well, if I take 12 away, I'll have one group of 12, which will be one whole thing. And 13 minus 12, all those twelfths becoming this one whole superglued back together thing, leaves me with one of those twelfths with a final answer of 1 and 1/12. Now, here we are seeing an example where we're using subtraction. Rosita had 3 pretzel rods. She ate 4/9 of one pretzel rod. What fraction of the pretzel rods are back? So each one of these bars represents one pretzel rod. We have 1 pretzel rod, 2 pretzel rods, and 3 pretzel rods. She broke this one into 9 even pieces. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9 pieces. And we got rid of 4 of them. So to do that, we're going to have to take 3, and we are going to want to chop it up into ninths. And we did this in our last lesson. I need to get them into ninths, and 1 times 9 would equal ninths. So I'm going to multiply 3 over 1, 3, by 9 ninths. 1 times 9 is 9. 3 times 9 is 27. Then I'm going to take away 4 of those ninths. That will leave me with, what do I got there? 23 ninths. Let me write that down. And then the question is, how many ninths, or how many whole pretzel rods does that take up? Well, 9 times 2 is 18, right? So that would be 2 pretzel rods. I'm going to write it up here. And then 23 minus 18 is 8, or is 5, sorry. Yeah, because 18 plus 2 is 20, plus 3 more is 23. So that's 5 left over, because 2 plus 3 is 5. But some of you might be saying, Miss Foster, why'd you make that so hard on us? We could do it a different way. And I'm going to tell you, yes, you can. So let me tell you a different way. Maybe I don't want to even break these up. Maybe I just want to deal with 1 broken pretzel rod. So then I could say, well, I know I'm going to have 2 whole pretzel rods, but I'm just going to take this 1 and divide it into ninths. And then I'm going to take 4 of them away. What is 9 minus 4? These are the bits she ate. 9 minus 4 is 5. So that's another way to think about it, being flexible with our thinking. Just as long as it makes sense, be as flexible as you can. Hey guys, thanks for playing math with me today. Have a great time playing fractions and improper fractions and mixed numbers. And bye-bye for now.